Now let's discuss the NMDA hyperfunction hypothesis in some detail. As just mentioned, this theory suggests that schizophrenia may be caused by neurodevelopmental abnormalities in the formation of glutamate synapses at a very specific site, namely at certain Gaba interneurons in the cerebral cortex. Something appears to be wrong with the genetic programming of those particular Gaba neurons that can be identified in prefrontal cortex as containing a calcium binding protein called the parvalbumin. These parvalbumin containing Gaba neurons are faulty postsynaptic partners to incoming glutamate input from pyramidal neurons in prefrontal cortex and thus form defective NMDA receptor containing synaptic connections. Thus, to summarize, they have hyperfunctioning NMDA receptors on their dendrites. They have defective synapses between the glutamate neuronal axons and the Gaba interneuronal dendrites, and thus faulty glutamatergic information coming in to the Gaba interneurons. This so-called disconnectivity may be genetically programmed from a variety of faulty genes that all converge on the formation of these particular NMDA synapses. As a consequence of this disconnectivity, they also have deficits in the enzyme that make their own neurotransmitter GABA, causing a compensatory increase in the postsynaptic amount of alpha-2 subunit containing GABA receptors of the postsynaptic axon initial segment of the pyramidal neurons they innervate. When these parvalbumin containing GABA interneurons fail to function properly, they do not adequately inhibit key glutamatergic pyramidal neurons in the prefrontal cortex, causing those glutamate neurons to become hyperactive. Thus, one sick synapse in a neuronal circuit can affect the whole circuit, from GABA interneurons and the glutamate neuron it innervates to downstream dopamine neurons and beyond, as is shown in the flowchart.